students, welcome to statistics class. We were discussing about normal distribution in yesterday's class. We have seen what is normal distribution, what you mean by normal distribution, then some of the features of normal distribution, and we have also seen the standard normal distribution and the features of standard normal distribution. Here, now before going into the problem, here formula normal variate, for example, now normal variate x with mean. Here in case of normal distribution, mean is mu and then one more parameter, that is standard deviation. But in case of the standard normal variate, we use the formula x minus mu divided by sigma. Z is equal to x minus mu divided by sigma. This we call it as standard normal variate. And here mean is 0 and variance is 1. Mean is 0 and standard deviation of variance is 1 here. Now in case of binomial distribution and Poisson distribution, you have seen writing that in case of binomial x equals b, then we used to write the parameters. That is, parameters are n and p. This in case of binomial distribution. And in case of Poisson distribution, x equals p, there also we used to write the parameter, that is lambda. For example, now lambda value is 1. But in case of normal distribution, how we need to write? There x equals n, and what is the value of mean? What mean value they have given? That mean value, comma, here we need to write variance. Mu and variance we need to write. If they give standard deviation, in the problem, we need to convert into this particular format, variance format we need to convert and we need to write. Then we need to write the standard normal variate formula. Z is equal to x minus mu divided by standard deviation is 0, 1. What is that 0, 1? That is 0 is mean and it is variance in case of standard normal distribution, parameters of standard normal distribution. These things you have to keep it in your mind, and this is the formula which we use in order to solve the normal distribution problem. Now initially this problem, it's a normal distribution problem and we are converting into the form of standard normal variate. X is a normal variate and Z is a standard normal variate. X is a normal variate, it is a standard normal variate. Now we'll see, we'll go through the problem. Listen to this problem carefully. Once if you understand, it will be clear. I'll go slowly, I will get into the problem. Now we are on the first problem. Read the problem there. If x is a normal variate with mean 64 and variance 144, find the probability that x is greater than or equal to 67 and x is greater than 60 but lesser than 66 and x is lesser than 62. As I said, here only 3 possibilities are there in case of question, either greater than or lesser than or in between, and all 3 will not come in a problem. Sometimes they will ask only 2. Sometimes in some problem it will be 3 possibilities also will be given. Now write the solution. What we need to write initially, what we need to write. Now once you, for your understanding, you write the mean and standard deviation, mean and variance value. Here mean is equal to 64, then here standard deviation they have given, variance they have given as 144, but we write in the form of This is the way of writing the variance. So 144, if we write in this format, it will be 12 square. We need to write in this format. We need to use in this format while presenting in the problem. Now here next is x equivalent n, that means normal distribution. So here write the parameter mu is 64, then 12 square. Now next usually we write x, but here x they did not give directly, they get into the, they have given mean and variance they have given. For example, sometimes heights of a students, weights of a students will be there. So in case we need to write heights of a students, heights of a group of a student, a number of the weights of a group of students. But in this problem they have not given, so they are not writing x. Then write the standard normal distribution formula. Z is equal to x minus mean divided by sigma is what? This is standard normal variance. This is standard normal variance. We are converting now by using this formula, normal variate x into standard normal variate z. Now see there, see the first question. We will move towards the first question. What is that first question? First question is probability of x is greater than or equal to 67. Now here what we need to do? Sorry, here we are not writing mu. Here we are applying directly 64 and 12. Here directly we are writing mean and standard deviation value. Now see the problem here. In the place of x, we are substituting this particular formula. Means in the place of normal variate, we are converting normal variate into standard normal variate. So if we write in this format, that will become standard normal variate. Now in the place of x, substitute this whole formula. Means P of, this is only in the place of x, x minus 64 divided by 12. This is in the place of x. Then write again that same symbol, write as it is. Now what we need to do with this? Here once again we need to substitute this particular formula, but where there is x, there we need to substitute this 67. Now see there, in the place of x, 67 minus rest of the things as it is, 64 divided by 12. Divided by 12. Next, P, probability of, as I said, what is this? This is nothing but standard normal variate z. This is nothing but standard normal variate z. In this place, you have to write it as, we are converting normal distribution, normal variate into standard normal variate. This is nothing but standard normal variate greater than or equal to, now calculate this particular value, 67 minus 64 divided by 12. What do you get there? There we get 0.25. 67 minus 64 divided by 12, if we do, there we get z is greater than or equal to 0.25. This is the 0.25 is the value of this particular thing. Now, what we have got here? Where is the, what z is greater than 0.25. Now we need to show their graph. Now we need to represent the graph. This is a rough presentation of graph. Rough presentation in the sense we are not using scale 1 centimeter or any centimeter we are not using. But this graph is very, very important. You have to show that this z, the place of the area of z, you have to locate in the graph. Now see here. Now here it is minus infinity and here it is positive infinity, and here comes mu, then here positive 1, positive 2, positive area of Z. Z is greater than 0.25. Greater than 0.25. Where 0.25 will come? What is the which is the place of 0.25? 0.25 will come on an average here. This is the place of 0.25. So greater than that, the area of Z, it is greater than 0.25 means this is the area. This is the area of that Z. So this is the area. I hope it is clear. Greater than 0.25. Lesser than 0.25 means this whole area will come. So since it is greater means we are moving upward. We need to go that side, right side we have to move. So this is the area of this Z. This is we located the area of Z in the graph. Now see here. Now what is the area? Now right here, area from where to where? Area from 0.25 to positive infinity. Area from, which is the area? Area from 0.25 to infinity. Now, this 0.25 value we need to find out from the statistical table. 0.25 value we need to find out from the statistical table. There in case of statistical table, for normal distribution, two tables are given. One is area under the normal curve from Z to infinity. From Z to positive infinity. Z to infinity means this particular value to infinity. This is the value of Z. One more table is there, Z to negative infinity. One more value, Z to negative infinity. Z to negative infinity. But now we are on the positive side. How we can say we are on the positive side? Because it is positive 0.25 and we know that this is positive 0.25. So you need to see in the table where there are positive values. See this side if you open there are negative values are there. So here it is positive value. Now here 0.2. First initially our value is 0.25. You see there 0.2. The row 0.2, we know that 0.25 is a fifth column. 0.2, fifth column, what is the value? 0.4013. 0.4013. This is about first question. I know that you might have got confused because it is slightly different from all other problems. Now once again I repeat, I go through that first question. Now firstly we are writing x equivalent, normal distribution. What is the mu value? Mean value they have given. And standard deviation, what variance they have given, that we are writing. This is we call it as variance. We are writing in the sense variance they have given, but we need to write in this format. That means the square, the standard deviation square is called variance. We need to write in this particular format. So we are writing here standard deviation square, and then Z is equal to, this is the formula of standard normal distribution. Here once again we are presenting the parameters mean and variance. Now first question, what they have given, probability of x is greater than or equal to 67. Now how we need to present this particular probability, how we need to solve this problem? In the place of x, substitute this formula directly. We substitute it. Then greater than or equal to, as it is. Now once again in the place of 67, we are substituting this particular same formula, but there we are substituting x, we are substituting 67. For x we are substituting here 67. Then this we know that is standard normal variate. It is greater than this, we need to calculate 67 minus 64 divided by 12, 0.25. Now this we need to we need to show or we need to locate the area of Z in graph. Here Z is greater than 0.25. So where 0.25 will fall? 0.25 will come here. So greater than that. So this is the area of Z. What is that area? 0.25 to infinity. Area from 0.25 to infinity. And this 0.25 value we have to see in the statistical table, normal distribution, positive table. 0.2, the row wise 0.2 and 5 fifth column. 0.2 fifth column we have to see. So this is about first question. Now we'll move towards the second question. What is that second question? Second question is probability of x is greater than or equal to 60 but lesser than 66. Now same thing, once again we have to write in the place of x, as I said, what we need to substitute. This formula we need to substitute. X minus 64 divided by 12 in the place of x. Now is greater than this, greater than or equal to 60. Now same formula, but in the place of x we need to substitute 60 there. 60 minus 64 divided by 12. Once again, lesser than. Here also same formula, but x we are substituting 66 minus 64 divided by 12. Now this I said, this we need to take it like it is a standard normal variable. Standard normal variable. We are converting normal variable into standard normal variable. This we know, this is equal to say the standard normal variable. Now Z, where is the position of Z? 60 minus 64 divided by 12. We get there minus 0.033 minus 0.033, and here it is 66 minus 64 divided by 12. Then we get 0.17. 0.17. Now this area we need to locate in the graph. This area we need to locate in the graph now. Mu minus infinity, positive infinity. So minus 1, minus 2, minus 3. Positive 1, positive 2, positive 3. Now see that. Minus 0.33. Where minus 0.33 will come? Minus 0.33 will come here. On an average it will come. Minus 0.33 will come in that particular place. Now this is the place of minus 0.8. Then 0.17. 0.17 on an average will come here. So what is the area? The area of Z, it is in between 0.33 to 0.17. 0.33 to 0.17. So here area from minus 0.33 to 0.17. Here to here. This is the area. How to find out the value of that particular area? How to find out the value of that particular area? Now, you see here directly we have taken 0.25 to infinity. Then we got the value of 0.25. Since we have here two values 0.33 to 0.17. Now how to find out this particular value? Now here in case of in between, where you get in between, it's always area from minus 0.33 to area from minus 0.33 to infinity minus from this value area from right here area from 0.17 to infinity. That we need to deduct. From this value, what we get in the statistical table. From that, for this value what we get in the statistical table, that we have to deduct. Now here how we need to analyze. From here, from this, see here, from 0.33 to infinity, from this, if we deduct 0.13, what will remain? This will remain. From this, if we deduct this will remain. That we have written here. From 0.33 to infinity, from that 0.17 to infinity, if we deduct. From this, if we deduct this particular area will remain. If you do not understand, make it very clear. From this value to infinity minus from this value to infinity. That you have to write. Now these two values 0.33 and 0.17 you have to find out from the statistical table. What you will get for that particular value. First is 0.33. That is minus 0.33. So we need to see in the page number 429. Minus 0.33. 0. That is 6293 minus 0.33. Sorry, 0.0 minus 0.33. Here 0.3 is there. From 0.3, the row by 0.3, column I see there, third column. That is 0.6293. 0.6293 minus, what is the value of 0.17? That is positive 0.17. That value taken from the statistical table, 0.1, then 7th column, 0.4325. 0.4325. When you deduct this, what do you get? That you have to write. When you deduct this, what you have to get? That you have to write in this particular column. Now, I hope it is clear. Till here it is clear. Now, in case of 0.25, you have to see only one particular value from the table. You have to see only one particular value from the table. But in case of normal, between, where you get between, you have to see there two values. You have to see there two values. Now, I was speaking about, in case of in between, you have to see this two values. In case of greater than, you will be having only one value. You will get there only one value. But in case of in between, you have to see two values. One 0.33, once again 0.17. Now, 0.6293 minus 0.4325. We get there 0.1968. This is about the second one. Now, if we move towards the third question. Now move to third question, that is x is lesser than 62. The probability of x is lesser than 62. I hope you are clear with the signs. This is in between, yes, greater than. Now, x, towards x, it is open. So, x is greater than. Towards x, if it is closed, then x is lesser than. This is lesser than and this is greater than. Now here, once again in the place of x, what we need to substitute? This particular formula we need to substitute. So here, p, x minus 64 divided by 12 is lesser than, once again same thing but in the place of x, 62. 62 minus 64 divided by 12. Now, here this we are taking it as z, standard normal. Now we are converting it to standard normal variant. It is lesser than, what do we get? 62 minus 64 divided by 12. We get there minus 0.17. We get there minus 0.17. So now Now locate this through graph. Here now area of Z is, see here, minus infinity, positive infinity, mu 1, 2, 3. Here minus 1, minus 2, minus 3. Now here Z is lesser than minus 0.17. Where minus 0.17? 0.17 is on an average it will come here. This is the place of 0.17. Lesser than that. So which is the area? This is the area. Lesser than that. This is the area. So area from, which is the area? Area from minus infinity to minus 0.17. Area from minus infinity to minus 0.17. Here minus 0.17. Minus 0.17 will come here, lesser than that. This is the area of Z. Now how to find out that area? How to find out the value of that area? See here, in case of less than, it's always area from minus infinity to positive infinity. What is the value of what is the area under normal curve? It is 1. Area under normal curve is 1. So here in case of less than, it's always how to find out the value. Area from minus infinity to positive infinity. Minus infinity to positive infinity. From that area from minus 0.17 to positive infinity. From this, if we deduct this, we get the value of Z. What is that? See here. Area from minus infinity to positive infinity. From that, if we deduct this area, from this area, if we deduct this area, what will remain? This particular area will remain. Z is lesser than 0.17 will remain. Area from minus infinity to positive infinity. From that, area from 0.17 to this. From this, if we deduct this, what will remain? This will remain. This area we need to find out. Now, it's always similar in case of lesser than. First thing, it is area from minus infinity to positive infinity. That value is 1. As I said, from here to here value is 1. Area from minus infinity to positive infinity, it's always 1. From that, minus. Area from 0.17 to infinity. Now 0.17 value you have to get it from the statistical table. 0.17, that is minus 0.17, you have to get it from that table. Minus 0.1, minus 0.1, there is 7th column. That is 0.5675. That is 0.5675. Now 1 minus 0.5675, then we get 0.4325. This is the value of less than. This is the value of less than. I know that you might have got confused, or you might have thought this problem is a bit difficult. No, it's not difficult. Go slowly. I have gone very slowly. In case of, I hope you are clear with the substitution. Where there is x, we are substituting this particular form. Then greater than. Where numbers will come, there once again substituting the formula. But in formula one more x is there. For that this number we substitute. We are presenting. Then this, yes, we know that is standard normal variable z. Here you calculate and write the 1. And this you have to show in the graph. Greater than means always it comes this particular side. Greater than means this side. Lesser than means this side it will come. Lesser than means my right side it will come. Then what greater than means my left side it will come. If we write like this, greater than will come, then right side, lesser than will come in the left side. Remember always when you do, greater than will come on your right side, lesser than will come in your left side when you solve this. So greater than, it has to be moved that side. 0.25 we got. 0.25 where it will come? In between 0 and 1 it will come. 0.25 greater than that. Okay. From here to infinity area. Here to infinity. This value take it from the table. Now in between same thing. X we are substituting the formula. Then where there is number, again same formula. But in the formula where X is there, substitute this particular value which they have given. And this is standard normal way. This divided 10 minus and divided 10, see what value you will get. Locate it in the graph. Here also we know 0.33 will come here between 1 and here 0. Here 0.17 also between 0 and positive 0.17. So that is the area. In between. In between means what did I tell you? How you have to write the area? Area from, it's always like this only. Area from what value will be here? From that to positive infinity. What value will be here? From that to positive infinity. Area from 0.33 to positive infinity. From that, area from 0.17 to positive infinity. That you have to deduct. From this value to this value you have to deduct. Find out the values from the table. And deduct and write there. And once you have to write the area from here to here. Area from 0.33 to 0.17. Then lesser than also same thing. In the place of x, that formula. Here also same thing, but where there is x, you have to substitute the number. Z is lesser than minus 0.17. Lesser than means what did I say? Left side will come. Where 0.17 will come? On an average here, in between 1 and 0. So lesser than this side. What area we have got? Minus infinity to 0.17. That is our area. How to find out? Minus infinity to minus infinity. Area from minus infinity to minus infinity. From that, area from 0.17 to infinity. Once again, slowly go through the problem. Once again, slowly go through this particular problem. It will be clear. I think with this we can wind up this particular session. One more problem I will solve in the coming tomorrow's session will be clear. It's easy, nothing to worry, it's easy, don't worry. Thank you.